Okay, this is section 1.6. We're talking about compound inequalities. When I think about compound inequalities, I think about compound words, which is two words that come together to mean one thing. So these are two inequalities that come together to form one set or make a union, and the union is one set. So um, this is some vocabulary that is involved. You're going to hear me talk about a graph, a subset, a solution of an inequality, and we already talked about compound inequality. So here's your targets. There's two of them. One is I can create and solve a system of inequalities, and I can interpret the solution of a compound inequality. So here's what they're going to look like. So you're going to have two types of inequalities. One is an OR. That means that your solution can be part of one part of the set or another. It doesn't have to be both. The ands, in order to be a solution, has to work for both of the inequalities. So this is just an overview of where we're going. Okay, so this is a really good example of what a compound equality is. It's two more inequalities joined by an and or an or. So this no parking sign shows that you can park here before 6 a.m. or after 9 a.m. This actually means you can't park there before 6 or after 9. So there is a small window that you can actually park there. So that's a good example. All right. So here is some notation. So you have two types of compound inequalities. You have your and, that's one type, and your or. So if you're talking about an and, it's called an intersection, and sometimes we use this little upside down U. It means that your solution makes both of the inequalities true. So usually and problems do not have the word and in them, but we'll see how they look. We'll see how they're written. An or is called a union, and it's the right side up U, and either one can be true. So you will always see the word or in these or problems. So your solution can be a solution for one or the other. Okay, so let's take a look at these. So let's solve this compound inequality using and. So the ands are usually going to have your x in the middle. So let's solve this. What you want to do is you want to get your variable alone in the center of the two signs. So I want to get that 9 out of there, that negative 9. So I'm going to add 9, but I'm going to do it to both sides of the inequality. So it's gone from the center. I have negative 5 plus 9, which is 4. And then I have 10 plus 9, which is 19. Keep the signs the same. No flipping is happening. Okay, so when you graph this, you're going to need to make sure you have either ends. So I'm going to go up by 2's here. I'm going to start at 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. All right, probably did more than I had to. So we see, if you remember, the ends are open for that symbol, and less than or equal to and greater than or equal to, the ends are closed. So I'm going to have closed ends. I'm going to put 1 at 4 and 1 at 19. So x is greater than 4, so it's that way, but x is less than 19. So your ands will look like this when you graph them. Okay? So this is an or, and there it is. There's your word or. So what we need to do is we need to solve both of these inequalities separately. So I have 4x is greater than or equal to negative 12. I'm going to divide by 4. So now I have x is greater than or equal to negative 3. That's one of them. Or Now we're going to solve this one. We're going to get x alone, just like we did in the last section. I'm going to subtract 3. Then I have x is less than negative 10. So let's go ahead and graph this. I'm going to start here with negative 10, and I'm going to go by ones this time. Okay, so since this left one is or equal to, is greater than or equal to, I'm going to start at 3, negative 3. Whoops. Let me go back. And it's a closed dot. And where are the numbers that are greater than negative 3? Well, they're to the right. So there's that half of the graph. Now, negative 10, I have x is less than negative 10, so that's an open dot. And the numbers that are less than 10 are that way. So that's how your OR is going to look, the graph for your OR. Okay, let's look at negative 3. They usually don't have the word and, but this one was out of your book and it did. So let's take a peek at this one. So we're going to solve this by adding 6 to each side. So x is less than 11. And then this one, x minus 4 is greater than 2. So x is greater than 6. And since this is said it was an and, like I said, you're usually not going to see that written. But let's graph this one. So I'm going to start with a 5 here. So I have x is less than 11, it's an open dot, and I have x is greater than 6, also an open dot, greater than 6, but less than 11. There's your and. This is open. Let me erase this so that we get no confusion here. It looks closed. There we go. Both open ends. Okay, so number 4. I'm going to change this. It should be on your notes as a less than. So I have negative 3x is less than negative 9, or negative 5x plus 1 is greater than or equal to 26. So we got to remember some things from last lesson here. To solve this, we need to divide each side by negative 3. And since we're dividing by a negative number, you're going to flip the sign the opposite direction. So I have x is greater than 3, or now here I'm going to subtract negative 1 from each side. So I have negative 5x is greater than or equal to 25. And again, I'm dividing each side by 5, so I got to flip. So x is less than or equal to negative 5. Don't forget to flip those signs if you multiply or divide by a negative number. So let's fill in the graph. I'm going to start at negative 5 here. So this is negative 4, negative 3, negative 2, negative 1, 0, 2, 3, 5, 6, 7. All right, so this is an OR. So I have x is greater than 3. That's going to be an open dot. And here, your numbers that are greater than 3 are this way. And then I have x is less than or equal to negative 5. So that's a closed dot because it's less than or equal to. And the numbers that are less than negative 5 are that way. So that's how that one looks. I think we have one more to do together. Okay, So this is an and this is how you're usually going to see ands. You usually don't see the ands with the words. So again, we need to get x in the center all by itself. So I'm going to add 1 in the center and each side. So I have 3 is greater than or equal to x, which is less than or equal to -1, which is greater than or equal to -1, sorry. Okay? So now we're going to graph these. Okay? So I'm going to use -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Got carried away. So on this side, I'm going to close in with a closed dot that -1, and I want to have all the numbers that are greater. They'll be that way. So this is an and. So I'm going to take my 3, and I want all the numbers that are less than 3. So that's my graph. Okay, I want to go back to the start because I want to show you something called interval notation. I'm back on number 1. So I can use a special kind of notation to show you what the graph is saying. So if I have these signs, I use parentheses. If I have these signs, I have brackets. So when I look at this graph here, there's an open dot on 4. So I would use a parentheses, and that would tell me what my left end of that graph was. And then there's an open dot over here at 19. And since it's open, I use parentheses. So just by looking at this, which is called interval notation, I can tell what my graph looks like. I could draw a graph from that. So let's look at number 2. Number 2. So this is an or. So this is when we're going to use these symbols. So on this side of the graph, I have starting at -infinity, goes on forever to the left. So I'm going to use parentheses. And then it ends at -10. It's an open dot, so I'm going to use parentheses. So now I'm going to show that this is an or with my U symbol. And now I have this side. It's a closed dot on -3. So my left side is -3. And it goes on forever. So that's infinity. And infinity always has that parentheses to close it up. All right. So let's just do one more in notation. So this is 6, the parentheses, and 11 with the parentheses on this side. That's an and. That's my interval notation. Here on number 4, I have -infinity because it goes left forever, and then it ends at 5. It's closed, so I'm going to bracket it. I'm going to use the symbol. And then here, I have parentheses starting at 3, going to infinity. Okay. So we got some word problems here. So we have to write an inequality from the word problems. It says the sum of 3 times a number and 4 is between -8 and 10. So we're going to put this in the middle. The sum of 3 times a number plus 4 is in between -8 and 10. So that's an and. So now we're going to solve. We're going to subtract 4 from all the parts here. So I have -12, which is less than 3x, which is less than 6. Now we're going to divide everything by 3. So I have -4 is less than x, which is less than 2. Everything gets divided by 3. All right, I'm going to start another video and catch you on part 2 of this.